works. Hello, and welcome to this Dyalog webinar. Today, I'm going to be talking a bit about data visualization and graphics in Dyalog. If you're watching on Dyalog.tv, I believe the chat should be working. So you can ask questions and my colleague will pass them on to me. You can do that throughout, or maybe I'll answer some at the end. We'll see how it goes. So, just a bit of preamble. We know that APL is great for data manipulation and data exploration. So things like a lot of the types of pre-processing that you'll have to do can involve things like selecting particular values or removing bad data, and that's quite straightforward to do. Or perhaps reformatting from, you got data from somewhere in a particular format, but whatever package or pipeline you're using needs it to be in some other thing, some other structure. It's also, fairly straightforward to do that. And exploring data is also quite accessible through the primitives and even some very powerful short expressions. So yeah, we know APL is great for this sort of stuff. But when it comes to just the raw data, sometimes it's hard to spot certain things. And this is where data visualization comes in, right? It's excellent for communicating ideas. For example, so this is a plot I think became, a little bit popular because of the Kaggle data science website. This is Antarctic penguins, 3 types of penguins, their culmen size, and I've attempted to put the mass on the bubble sizes, but the range isn't big enough and it doesn't come across well. So that's there's an example of what not to do. But you can still see things like, we can try to sort of guess about the properties of these penguins. So on the y-axis is the length of a penguin's culmen. If you don't know what that is, it's the top ridge of the beak. So you can see that there. That's measuring the culmen length with some calipers. And on the x-axis we have the depth. So you could tell things probably just by looking that you have these sort of 3 distinct groupings. Let's have a look. The Gen 2 penguin, it should have sort of generally longer beaks, long and a bit wide, I guess. So I don't know. Let's take a look. Let's take a look at some of those and see if we were right. I guess it's hard to tell without the other ones there to compare with, but I suppose the data is the data. Then our chin strap penguins, they're going to be the longest and chunkiest beaks. And these Adderley penguins having short, stout ones. Chin strap, again, hard to tell with these particular penguins when you haven't got them side by side. What's that? That's Adderley, and it's deep, short. Yeah, I guess you can see that. So hopefully we've correctly inferred the properties of some penguins from this graph. It's also, useful in data visualization to try and be a bit more concrete when you're trying to discover patterns. So here I've separately plotted some trend lines for each of the different species of penguins. Anyway, I won't go, it's probably already too many details. because what I actually want to talk about today is a bit more of the technical side of data visualization with Dyalog. So for those who are interested, want to know, what technical solutions exist, how do we plug things together, then that's sort of most of this. I'm going to talk about a package that comes with Dyalog called SharpPlot, and a sort of new kid on the block, well, relative to APL, is called Vega. And these are two data visualization, well, one's a plotting library and the other one's a sort of, well, they're both plotting libraries, but I'll get into the details in a moment. Then I'm going to talk a bit about the interface or the graphical sort of frameworks you have for putting, where's the y-axis label? Maybe I shouldn't answer questions as I go. That's a good spot. Maybe we can fix it later. That is just one of the mistakes and errors that I haven't fixed. Right, sorry. And yeah, so so after the plotting frameworks, I'm going to talk about the graphical frameworks for when you want to actually use your visualizations in an application. And then a little at the end, I think I'll talk a little bit about some other third-party data visualization things and some speculation about what the future of plotting with APL could be. So yeah, sorry Curtis, I don't know, we'll see if we can fix that y-axis label in a bit. Maybe someone can help me. So previously, there have been, a few pieces of particular Dyalog media that are worth checking out to do with this topic. So the history of plotting in Dyalog is fairly long, but Rain Pro was this APL workspace for generating graphics, and at some point that got converted from APL into C# and also refactored into this product called SharpPlot, which in 2013-14 Nicholas Delcross took over the development of, and he evolved that into, so the C# version was sort of so that it could be used in the kind of ASP.NET web applications at the time. Nicholas created a cross-platform APL workspace again, but it also has additional benefits of, if you're using Windows, it will tap into the DLLs to have faster plotting. But the same scripts will work across platform. We'll see that in a second. Well, not across, anyway. Then in 2018, Brian Becker presented that in a kind of context of, the cross-platform charting solutions at the time. SharpPlot for producing graphics, in particular SVGs, and I think Sync Fusion as well as integrating them into DUI. So while I'll mention it, I won't go into too many details. You can watch that video to find out more. And then most recently, Nick came onto the APL Orchard and helped instruct about sort of simple, basic plotting things with SharpPlot. So if you are just getting started with SharpPlot, then I can recommend reading APL Cultivations 44 and 45. But in any case, I'll talk quickly about the very, very basics. So yeah, as I said, Nick turned SharpPlot cross-platform. However, the code examples are all in C#, so you have to translate those. And while there is a sort of Rosetta Stone of translation, and I'll point you to where you can see that. I still find the argument nesting issues a bit fiddly, that sometimes you have to enclose arguments, sometimes you're not supposed to, and so that's just a bit of a gotcha to watch out for. But otherwise, the basic principle is that SharpPlot is a state machine, so you kind of set things up and you add and you add and you add to your setup until you are ready. Then you call the draw functionality, and that draws to your page. And then if you want to add more stuff, you can go back, set some more settings, and then draw a different thing. And while that's not particularly mainstream in modern plotting frameworks, the concept actually means that you can have arbitrarily complex plots. Anything that you sort of, based on what's available that you imagine, you can just stack those things on top of each other. And then in terms of cross-platform, I'm going to mention this quite a lot, but I personally like to render SVGs a lot. But SharpPlot can produce lots of types of formats, which we'll get to in a bit. So, as I said, the documentation, on Windows there is an inbuilt CHM help, but it's actually just identical to the SharpPlot website, or rather the content was moved to the SharpPlot website. There are some chart samples, there's sort of a list of pages, but if you want to get a quick overview of what's available, then the SharpPlot methods page has this kind of list of little visual icons of which types of plots look like what. And also Nick's 2013 user meeting presentation also covers the types of plots available and which ones are more suitable for which type of data visualization. And the languages page, if you scroll right down to the bottom of that, then you have the cross-platform charts in Dyalog APL, which is basically the instructions for how to translate them. But as I said, you will still get tripped up by the nesting for sure. So that's the basics of SharpPlot, and I'll show a demonstration in a moment. But I quickly want to touch on this software here called Vega. So Vega is a JavaScript. It's a JSON grammar for describing basic plots. So the kind of context here is it's based on a framework called D3. And D3 is an incredibly powerful JavaScript library for manipulating SVGs ostensibly, but the entire document object model of web browsers, I guess. So it's based on these like core data-driven transformations, and that's basically allowed people to take that core framework and develop any kind of visualization you can pretty much think of. Unfortunately, it's all in JavaScript. And it's also kind of a bit heavy to get into at the start. So for that reason, some people developed something called Vega, and then on top of that, even Vega Lite. And it's basically going higher and higher level descriptions for common types of graphics. But then the output becomes this SVG that you can manipulate directly using D3. But the nice thing about Vega, although the demo I have in particular is this Vega Lite, are these definitions using JSON. And that means that you can either, handwriting them gets a bit unwieldy, but at least you can kind of see what the properties are, and you can edit these directly in a text editor fairly reasonably. But also on the other side, from the APL side, we have Quad JSON. So this is an opportunity where you can have a fairly straightforward to use way of building up these definitions, or rather translating from the examples that you'll find on the internet into an APL script you can actually use. There is a piece missing from this, and we'll get to that just about now, because, well, that's kind of, you know, two frameworks that you then have to go and learn, and the bulk of that is just reading loads of documentation, figuring out how to grok the examples and learn the principles, and maybe even translate those examples into something that you can work with. As Nick says in one of the APL cultivations, I guess the interesting part is figuring out how to embed charts in whatever it is you're trying to do. So as I said, this is actually pertaining to SharpPlot. You're basically living in two worlds when you're doing software-based data visualization. You either want to produce graphics for publication, literal printed page, or PDFs. And for that, having a high-resolution raster image is probably, you know, will do the trick. But recently we're seeing developments that mean that raster images aren't quite cutting the mustard. People are reaching out to other formats, vector-based formats, which means that the rendering software will let you scale it however big you want. Two that SharpPlot can produce include SVG and XAML. I think XAML's like a Microsoft-y thing, and SVG is the same thing that Vega uses. And then you can embed these things if using QuadWC Windows forms, Quad New Forms, maybe I should put. Then unfortunately the native .NET renderers don't actually render SVG, but yeah, I'll talk. I've got a little bit on that discussion in a second. And an HTMLRenderer is the cross-platform HTML renderer. It's a sort of browser engine that comes packaged with Dyalog, and that's an alternative that you can use. So yeah, for SharpPlot, there is the plot user command that comes with Dyalog. The other nice thing is that there's a cover for this in the Dyalog Jupyter kernel. So if you're writing Dyalog Jupyter notebooks, you can just call the plot function. That's pretty straightforward. But it's fairly limited, and it's not long at all before you find you want to actually just write some SharpPlot. Typically, when you see the tutorials, you have this, which is I'm going to draw this line chart, and then I'm going to use the view function from SharpPlot library. So on Windows, this is a .NET based viewer, and it lets you sort of scale the image and stuff, but actually what it's doing is re-rendering a raster image at different resolutions as you scale up and down. It's not actually a vector image inside, and I think for the way that this works, that has the sort of performance benefits. On macOS and Linux, however, the view function literally just spits out an SVG and then shows that in the default viewer, which is partially why I keep going on about SVG and why it's probably what you're going to end up using if you're developing graphical applications in the future. But you can still embed SharpPlot in Windows GUI. As I said, you know, it doesn't render SVG by default. There was some discussion recently on the Dyalog forums about how to deal with the fact that you know, people are using high resolution screens these days, and they want the graphs to look just as crisp. So I want to say thanks to Pierre Gilbert for providing these samples for embedding WPF Viewbox with XAML. into Windows Forms. The only unfortunate thing apparently is it can be a bit slow to render compared to the other formats. And I'm afraid I don't have an answer to the last question about directly embedding the SharpPlot viewer. But I will ask the people in charge about that. So then the other thing you can use is the HTML renderer. And this does handle SVG. It's cross-platform, and you also have the other aspect that I'm kind of leaning on today is this fact that graphical interfaces are sort of, for a lot of people, are defaulting to using a web stack. So this is learning HTML, CSS, and JavaScript. And the benefits of this are kind of plain because everyone's using web browsers all the time, and the HTML renderer is just a web browser that comes with Dyalog. So if you develop your applications in a way that uses this web stack, then you can hopefully plug it into a desktop HTML renderer application just as easily as you can serve it so that people can access it via a web browser. I've also been informed that if you're on non-Windows, yes, you throw SVGs at 3500 IBeam, which is that like the RIDE in-memory browser viewer. I guess it's just a bit sleeker, or not sleeker. Does it use less memory than spawning an entire HTML renderer? So yeah, so for that purpose, HTML renderer, I do have a very small, partially baked demo. So this is the script to process the penguins data for that chart, and maybe we can even how could you use SVG to render a Mandelbrot image? That's a fair point, and I think, sorry, I'll answer this question. Yeah, I'll answer this question first and then come back to the demo, I think. Ray Cannon asks, how could you use SVG to render, for example, a Mandelbrot image? The problem is that Mandelbrot doesn't lend itself to vector graphics. It kind of needs bitmap. I'm trying to think of how many other things have this property, because, I mean, you've chosen that one because it's a fractal, meaning that it, I mean, by definition, technically has like an infinite amount of detail, but of course, you're going to be limited by your eyes and screen resolution when you actually see it. I think oh, just a dodgy link. I think it's a fair point. It is possible that using one of these vector manipulation frameworks, you could do something where you have the equations, right, that generate the Mandelbrot set, and then with the vector graphics you kind of render at different scales. And Adam points out you can also use Morton's BMP renderer. Well, that's for the actual rendering, right? In the HTML renderer. I mean, right, websites web pages serve all kinds of images, so I guess that's I sort of was taking that for granted, that it's not just SVGs that are useful for serving graphics into graphical applications. It's just that it's one that's got a lot of traction, a lot of bang for your buck in terms of what you can get out of it with fairly little effort. So I should mention at this point, you know, I've got a few links from before, and you see I've obtained another one because I just remembered this blog post from Nicholas about making images of the Mandelbrot set. So I'll pop these in the description afterwards, so that people watching in the future or from tomorrow will be able to find all the links to all of these things and the BMP renderer. All right, that was a fun little detour. Okay, I need to bounce through this and then do some wrapping up. So, just for the sake of people who haven't seen it before, which is probably not a lot of existing Dyalog users, but maybe some new ones, this is what the script I used to generate the SharpPlot is. So the first thing I have is some data in my workspace, which is just brought in from a CSV. Species, island it was measured, all the measurements. Then, as alluding to one of my first slides, there's some missing data. So I just got this simple expression to just find rows with NAs in and get rid of those because I'm not dealing with that right now. And then just splitting up into each of the different columns to make it easier to deal with later on. Then this is the one point I wanted to make about the SharpPlot viewer and the plot user command. The only thing I find a bit fiddly is every time you want to look at your plots, like popping up a new window, and especially on Windows, now I've got to move that across, and then if I want to do it again, I've got to pop up a fresh window. So it's not that hard to, please ignore the caller stuff. I was trying something out to do with making this easier to handle in terms of returning an HTML renderer, but I should have just returned it as a oh, and also using Causeway in other namespaces. But I think I consider this a failed experiment because if you were doing a real application, you don't want to initialize Causeway in oh, this only does it here. Okay, it was a different script where I was initializing it in the caller namespace. Sorry for that tangent, just ignore that. Right. Yeah, so you know, what I find useful is just pop up a little HTML renderer, stick it on the side. The HTTP request stuff, maybe I'll show one thing of it, but it's me trying to experiment with interactivity, not getting particularly far. Does this work? Oop. Yeah, it works. So yeah. I'll tell you where you can go to actually make progress on that later. But for now, it's just setting up an HTML renderer. Right, now the meat. So you create a new SharpPlot. Then you do all the setting of settings. Set my ranges. Set some styles. I'm going to put a link to this script. Or put all the scripts. I'll put all of the examples on GitHub afterwards. Yeah, when you read the Rosetta Stone, you can see what the magical incantations that you need are, and whether or not you need to enclose things or not. Here's a good point. It was mentioned that the caption was wrong. Now, I believe you can set the caption sideways, but I haven't actually seen how you do that. So if that's called Y caption, right? You can see me setting the Y caption. We can have a look at the HTML renderer. Maybe someone can paste in the chat how I'm supposed to do this before I get there. So I've set all my settings, then I do the draw of the thing, which in this case is this bubble chart, but it might as well have been a scatter plot for this particular data. and then I inject it in the page, which, as I sort of alluded to earlier, more in the context of Vega, because missing assignment, is that what it is? Oh yeah. GG, too easy. Okay. Well, so it's going to draw the thing on top of the thing, but because I've only changed one thing, then I'd hope it would make it visible, but maybe not. Let's try that again. So the one curse of the state machine of SharpPlot is that you do have to go back and start a new one if you want to change certain things. That's definitely assignment. Hey, thanks for spotting that, eagle-eyed viewers. And that's how we do it. Right, yeah. So at the moment, in the kind of raw HTML renderer world, I'm doing some kind of hacky piecing together of JavaScript expressions, statements that are then execute using the renderer. But I'll talk a bit in a moment about the developments that are currently happening that will hopefully make that much smoother for APLers. So yeah, so then the last part of this then, I guess, is the fact that I've drawn this bubble chart that's been split by species by the SharpPlot renderer, but then I want to plot the trend lines on each of the species rather than as a whole. In fact, maybe this is a nice demo of something called, I learned it was called Simpson's paradox, where if you, let's see, we've already set the scatterplot style to model fit, but if instead of plotting them separately, I draw a scatterplot now on all of the data together like I did for the bubble chart. So that's length, depth, mass. And I get a length error because I was supposed to enclose it because it's a single series despite being made of 3 things. Okay, double. Oh, and also it's not a bubble chart, so you only need 2 of the things. And then it is 2 series because I'm an idiot. Okay. Well, that's what you get for doing demos live, isn't it? Yeah, then, you know, the model fit of the overall data shows this slight negative correlation. But of course, us with our eyes can see that's not quite right. Shouldn't have pressed escape, wasn't editing. It's okay, because I'll just start it again. Yeah, us with our eagle eyes can see that actually there's generally this positive correlation between the Coleman length and the Coleman depth, which I guess makes sense. Bigger beak is bigger beak, is it? So I've used key to group by species and then plot the individual models along using scatter plots with invisible markers. So it's actually SharpPlot doing the fitting. And you can also get those values, which is kind of useful for your actual quantitative data analysis, right? It's not just arbitrary lines. They probably mean something, and you probably want to know what that is. And then I found one little bug, which I'll report, which is that for some reason on the third loop, it's not drawn the thing. Although there's a fair chance that as soon as I do that, whoever knows is just going to tell me that there's a better way to draw those lines. All right, so that's a sort of example of SharpPlot and then injecting the SVG into an HTML renderer. And from that same SharpPlot object, you can just Let's see, I kept that global, didn't I? Did I? Yeah. You know, you can just save SVG. I think I called it penguin1.png because I'm a hack and I talk all this about SVG but then end up using a PNG. Right. Bear with me one moment. I thought I had this folder open. You know what? You don't need me to prove to you that you can save an SVG. What am I doing? I can save a PNG even. But I'll do it anyway. You know, it's Windows viewer acting up. Right, moving on, because that's just getting in the weeds. Yeah, I guess the other thing that's slightly interesting, but it is like even more half. You know what? If there's if people are still interested at the end, I'll come back to that. But I'm going to move on because there's not much more to say other than. Okay, very briefly, you'd be surprised to know, or at least I was, SharpPlot, despite being touted as like, you know, not exclusively for print graphics, but it's definitely really well suited for print graphics. But what I mean is, interactivity isn't necessarily its strong suit, but turns out you still can do some stuff. In particular, you can add handles in JavaScript handles to the paths of the SVG and make them at least clickable. And then from JavaScript, you can probably do all kinds of other things. But of course, that does raise the question a little bit. You know, at some point, you're just manipulating SVGs with JavaScript. And, you know, if I don't want to write JavaScript, then why am I recommending all this? Well, there's already at least one ways that you can produce web stack interfaces without writing any JavaScript or HTML or CSS, or at least JavaScript. You don't have to write. One is Dyalog user interface, or DUI, name my server. So the GitHub repository, I guess I should have put a link on the screen there, will be on in the description. DUI is the evolution of my server, where basically, where my server was strictly a web service framework that would serve your front-end code so that you could access it via a web browser. DUI also adds the ability to run that graphical application as a desktop app, just using HTMLRenderer. And then the great thing about this idea is you write one code base and all of your callbacks from the front end to the APL side, all those callbacks work just the same whether you're serving it to a web browser or using the HTML renderer. Sorry. So apart from I guess one kind of neat. Well, hold on. Okay, all I'll show of this is it's pretty straightforward when you get down to producing the thing, even though there is like this whole framework behind it. This is a simple page. DUI is class based, so you make these class scripts with a compose function that sort of sets up, here's what I want in my page, but then you can also add other functions to act as callbacks and all kinds of other things. Won't go into more details because there's a previous webinar with Brian doing a much more full demonstration of that. But just for sort of completeness, you download DUI from the GitHub site. Typical way to do this right now is you go to github.com/dialog/DUI, and click on code and download zip. And then you get the zip folder, and currently got to unzip that and then point load user command to, or you can do quadsc.salt.load just as well. And there'll be more on this particular topic of loading stuff in and out the workspace coming this year. But was I going to mention it? I don't have the latest version of get. The get user command coming in Dyalog 18.2 I think should maybe allow you to unpack the DUI. No, because load, it's based on salt and has all this other stuff. Right, ignore what I was saying there. Let's move on. So you load it, and then you do DUI.run, and you point it at a folder, which I'm currently in the Dyalog data visualization folder, and I have a folder called my site. That's some experimentation. The only thing that actually matters is index.mypage. That's the only functioning thing in here, and you just pointed at that. Am I there? Sorry, it's called my site. What is happening with me today? Well, that's recorded now. Yep, alright, there's a plot. With some basic JavaScript hovers that aren't very good or useful, but that's not really the point. Okay. Wow, this was going to be way shorter in my head. Let's move swiftly on to just say, that's how you obtain and use DUI. To learn how to write the pages, go to the myserver.dialog.com, the sample site there. But now I want to move into the more experimental side, because there's some quite interesting developments happening in the ostensibly HTMLRenderer world, but I have a sneaking suspicion that it will leak out into that similar, the same idea as DUI. You write a code base, you can serve it as a web app, or you can have it as a desktop HTML renderer application, depending on your needs. And that's Carlyle Group's Abacus. Kind of interesting. Only want to mention it briefly because it's just a sort of different approach to the idea. So it's like, should I do a little demo? Maybe at the end. This is getting on. I'll post a link to demonstrations in the description. I guess what I can show at least is no, it's not mine to show anyway. I was going to show get because I'm just so excited about it, but that's for next webinar really. And that is, if you download Abacus, at least the application from the releases, then you can unpack that. But I guess it's the same as a quad CY, so what's the difference? Right. Sorry, just to wrap up this part, Abacus is the idea behind it is you have a sort of model of the document object model, the DOM, in APL. You build up your graphics like that, and then there are functions which translate or convert from Apple DOM to HTML or HTML to Apple DOM. And then you do all your logic in APL, and then just spit out the HTML at the end. I think you've still got to learn at least CSS, is what I've been told, but maybe you can get away with basically no JavaScript. I think. So that's exciting, but I didn't do it very much justice. One other thing I wanted to kind of give a little shout out to is this, what do you call it? It's a framework again. Well, it's a notebook system called Observable. It's made by the same people who are making D3. And the one thing that's, I guess, the most nice about it, so similar to Jupyter Notebooks, it's a way of doing this kind of literative programming. You put your descriptions and then you put your code, and then also your graphics will come out. I'll show you that in a second. All in one kind of space where you can read the whole thing nicely. I think that fits well with the sort of Edward Tuftian perspective on data visualization, where you should present it in a way that gives the recipient, time and space to digest the information properly. I know I've mentioned briefly interactivity. I think for a long time it's been largely dismissed on the grounds of being superfluous, and I think a lot of the fancier things still are. The one thing I can see being really useful is a sort of persistence between transformations. But anyway, sorry, this is the kind of rambling I was saving for the end. Let me just show you the sample. Right. So in a similar way to how you kind of have to interact with the HTML renderer at the ground level at the moment, or if you build an app in Jarvis, which is how I'm going to demonstrate this, you have to have a little bit of JavaScript boilerplate that does a little callback to the APL side as a web server. But yeah, with Jarvis, you can quite easily expose your APL functions. So, I do get to demonstrate it. So one thing you can do is obtain Jarvis from the internet. So this is literally, actually might as well go through the steps here. It's kind of useful. Go to the Jarvis site. At the moment, the way to do this is go into the source, right click, copy the link to the jarvis.dialog scripted namespaces, and paste that in with the get user command in Dyalog 18.2, and then it just brings that into the workspace. And then because Jarvis is a single scripted class, you can just get started using it. So create a new one, set the code location to, I hope it's here, the way these demos have been going so far. Set port, start the thing. So now it's serving that up. And now my observable notebook, is it Shift Enter, Control Enter? There you go. Boom. So this APL function just takes the name of a function that I've exposed in my workspace. So sign 1000, and that's this array of 1000 data points. That's the same as if I go app.sign 1000. Oh yeah, hope the numbers are the same, sorry. Can't believe it moved. 682, 628. But then, the nice thing, though maybe I should save this for the demo, although the way it pops up is kind of nice, is on the right hand side here, I think, click add. You've got these snippets, and here's a bunch of basic plots that you can shove in. So here I just created the sign plot, and I had to add, increase browser font size, no problem. Actually, if I add one, which is the same again, you can see it comes with like, I'm not sure why I have to is that the name of the data? Yeah, you have to basically fill in what the names of the variables are going to be, and again, that's a bit JavaScripty, so if you're allergic to JavaScript, probably not going to be the best time. but it is kind of a neat way of, sorry, you probably want to see some of these things. Yeah, it's a neat way of displaying and sharing data visualizations. And in particular, if you're worried about it being an internet-y thing, Observable basically just serves the interface to your web browser, but all the data you use, I mean, I think there are ways to attach, to bring, bring stuff into your notebook to save, to package it with the notebook. But ostensibly here, the data is just in my web browser. It hasn't gone to Observable servers or anything. I think they've deliberately set it up so that you can do things securely if you have to. All right, so if you got sensitive data or whatever, yep. So anyway, I just wanted to briefly mention that because I thought it was kind of neat and fairly straightforward to do. I didn't expect that I'd spend so long, but that basically concludes the technical stuff. I don't have much to say about these slides anyway, except I wanted to point out this is the general speculation and pontification bit. Edward Tufte is the guy who's kind of the inspiration for the way that SharpPlot is designed as a graphics package, the types of markers and visualizations it chooses to let you use, and the way it lets you put those together, and have, like, for example, multiple plots next to each other. That's one of the sort of key points of Tufte's that gets bandied around, is instead of trying to stack all the information onto a single axis, you're better off separating it out in some way to make it more distinct. But there are other sort of theoretical developments that are worth having a look at. So one is Jacques Bertin's semiology of graphics, which is a fancy way of talking about mapping visual properties to data relations, and then later Lee Wilkinson's grammar of graphics. And these are kind of taking a step back and developing sort of frameworks in a more general linguistic sense for talking about data visualization and actually doing them. And in some ways, these two are the inspiration for, ggplot2 is a literal implementation of the grammar of graphics in R. And then D3, as I said, is this framework of data manipulations, data-driven visual transformations, which then you can just build and build and build on top of in the same language, in R or JavaScript, and create this entire world of data visualizations. So, the reason I mentioned this is not to get disheartened. I think what do I want to say? I think it is an interesting route to investigate if we could have something akin to this, where the issue right now with both SharpPlot and Vega, and even and basically all the other frameworks. Okay, no matter what, you're going to be reading lots of docs. That's just what data visualization, that's what programming and everything is like. You're reading lots of tutorials and documentation and learning stuff. Right now, you with SharpPlot and Vega, you do have to learn something that's a framework or something that isn't APL, and then spend a lot of time translating code examples. And also, I thought I'd mention, you've got to alter your data to fit the framework. But as we know, in APL, that's definitely the easy part. But, you know, wouldn't it be nice if we had some kind of APL graphic manipulation framework like those? I know I haven't really shown them in any depth, and I've got a typo there. But I think, yeah, I hear on the grapevine, along with the Abacus work, ways of directly generating the SVG from APL is being worked on. I shouldn't say too much because I don't know too much. I also think there's probably an interesting avenue for APL-based tree manipulations in order to get high-performance versions of this, because as you saw, you know, very, very briefly I showed it's very easy to use quad JSON to build up Vega definitions in a fairly usable way, but you can see I'm generating all these nested object structures, and that's at a larger scale, that's not going to be very performant. So I've surprised myself by using up the whole hour, but that's what I get. So I guess all that's left to say is here's some stuff that's coming up. So continuing on, the webinar schedule for 2022 is the British APL Association. So that's next week, 24th of February is another open session. Then in 4 weeks' time, on the 17th of March, will be a webinar. I was getting overly excited there about the get thing, but I'll but it's going to be about, at least to some extent, link and sharing code, maybe a bit of GitHub, but we're trying to make it digestible for people who aren't into that, or maybe I can frame it in a way. And then, you know, plans are in the works. Don't have the exact date yet, but it's going to be around the 30th March. APL Seeds 22, Apple Seeds 22. Am I supposed to pronounce the pun or not? I can never remember. APL logo voters, give me your comments. A Dyalog online user meeting will be via Zoom again. But targeting new and prospective APLers. So if you if you know people who you think might be intrigued by APL but just need an excuse, some specific date or something to give that little push, then you can send them this way. Okay, I'll answer this one question before I probably should get off, because we said we weren't going to be doing long webinars, and look what I've done. But that's what I get. I call it another in my series of Richard bites off more than he can chew. But the question from Ray Polivka: in teaching APL to beginners when they wish to plot data, where should they go and do it and learn how to do it? And right now, and this is why it was such a large focus of the beginning, it's still very much SharpPlot and the SharpPlot viewer. So in particular, and maybe this will make a nice short video that maybe just summarizes this exact part. But sharpplot.com, you don't have to worry about installing it, but the key, because it comes with Dyalog, but the key part, I guess your first chart is going to be the place to start. But before that, you'll need SharpPlot in different languages, because as I said, the current state of affairs is you're going to be reading examples that are actually written in C# and then translating them across. It's a nice opportunity to learn, I guess, about namespaces, classes and other object structures, nested data structures, and enclose and stranding as well, because that's all over the place. As long as you have those in your pocket and then you know the data, then you can probably get started with your first chart. And then there's the stuff about rendering images, but as I say, if you set up, well, to start with, you'll just want to use probably the viewer. So that is initialize, copy causeway in, and you can copy the view function from the SharpPlot workspace. Initialize causeway, and then, I mean, this whole thing's a trad a traditional function. Oh, this one says render SVG. But you can also do view SP, as I mentioned at the beginning. Yep, so that was a whistle-stop tour. Thank you of all kinds of stuff to do with data visualization. Thank you for joining me on that ride, if you're still around. I'll hop off now, and maybe I'll pop into the chat for 5 minutes, but thank you very much for watching, and I'll see you in the next one. If it